is common occurrence for people, especially elderly group. Time between the fall impact and the first aid delivered is crucial. Therefore, a system must monitor the elderly continuously to detect the fall. Introducing the Elderly Monitoring Tag System. Elderly Monitoring Tag System uses sensor tag CC2650 devices to monitor the elderly condition. This is done by sending accelerometer access data from the sensor tag to the listening server. The listening server will then run the necessary algorithm to determine whether a fall has happened. However, this method requires the sensor tag to send the data continuously for real-time monitoring, and it consumes a lot of power. Therefore, the objective of this project is to develop an elderly monitoring system with reduced power consumption by reducing the radio frequency communication. This is done by moving the necessary algorithm from the listening server to the sensor tag devices. The sensor tag will only send data when requested by the listening server or when a fall is detected. There can only be one listening server connected to the sensor tag at a time. But there is multiple listening server covering different area giving a wide coverage area. There is a special listening server called main listening server. The main listening server duty is to update the database containing the ID of the device, associated elderly, and the location of the device. The other task of the main listening server is to coordinate with the other listening server by deciding which server should connect to a sensor tag device. When the elderly wearing sensor tag device move to another area, all listening server will receive a broadcast message containing the device ID and signal strength. The listening servers will send this information to the main listening server. Based on the strength of the received message, the main listening server will decide and send the command for a server to connect or disconnect from a device. Other than detecting fall, it is also important for the monitoring system to be aware of the overall health condition of the elderly. The overall health condition could be determined by knowing how active the elderly is. By using step detection algorithm, the number of steps taken by the elderly will be stored and could be fetched by an administrator to see whether the elderly do enough activity. Another method, which is calculating the average activity level, could also be used. By comparing the activity level with a baseline of normal activity level, we could determine whether the elderly is more active or less active than a normal level of their peers. We could also detect sudden changes in the average activity level. Sudden changes could indicate emotional or physical illness which cause depression and surge or drop in activity level. The experiment results show that all simulated falls is detected, while the power consumption is reduced by approximately 20 times. Steps could also be detected with an error of plus minus 1 for 5 steps and plus minus 2 for 20 steps. However, sometimes 1 or 2 additional steps are detected, resulting in 23 or 24 detected steps.